All right. Actually, I'm going to start over. So we're here Monday, August 24th for introductory chemistry. And today we're going to learn how to draw atoms and to write what are called electron configurations. And they kind of go hand in hand with each other. If you do that, there is a principle called the Aufbau Principle, which I don't particularly like. I like to just look at the periodic table. As long as we know the SPDF structure of the periodic table, we should have no problems doing this. So to do this, we're going to begin at the very first element, hydrogen. And we're going to build our way up until we have 16 electrons for a neutral sulfur atom. So I'm going to begin. So your finger should be on hydrogen, the very first element on the periodic table. So I'm going to put this is our nucleus here. And let's see, what period is hydrogen in?
1.
Hydrogen is in period 1, so I'm going to draw a ring here. And over here, I'm going to start writing the electron configuration. Period 1, and hydrogen is in S block, so I'm going to write 1s. Now, how many electrons can fit in S block? Now, to answer that, we're going to think of helium. Remember I said earlier in the year that we're going to make a lot of statements throughout the course, and sometimes we're going to say except for hydrogen, we already saw that in first class, or we're going to say except for helium. That's going to be, and we also saw that in the first class, number of valence electrons in a helium atom. So we should think of helium as being over in group 2. All right, we know it's really in group 8 because it's an inert gas. So for this purpose, we're going to think of it as being over in group 2 next to hydrogen. So there's 2 positions in period 1 S block. Notice there's two groups, so 2 columns in S block, right? We have group 1 and group 2, the alkali metals and the alkaline earth. So 2 electrons can fit into S block. So I'm going to write 2 electrons here, 2 electrons. So there's hydrogen, there's helium. Here I'm going to write period 1 S block, 2 electrons. And my counter begins at 2. So our finger should be on helium right now. What's the next element after helium?
Lithium.
Lithium, which is in what period?
3.
In period 2. Lithium's in period 2, so I need a new ring. The ring is, if you haven't caught on by now, the ring is equal to the period number. So I have second period because lithium's in period 2. Down here, the electron configuration, I'm going to write period 2, S block, and again, how many electrons fit in S block? 2. 1 for lithium and 1 for beryllium. So I'm going to come and put those up here. Lithium and beryllium. Down here, period 2, S block, and 2 electrons, right? Lithium and beryllium, right? Up here, my electron counter goes from 2 to 4. Now this electron counter is going to tell me when to stop. When that hits 16, I'm done. Okay? So my finger is on beryllium right now, right? Beryllium. What's the next element after beryllium? Come on, somebody speak up. Boron, which is still in period 2, so I don't need a new ring. I don't need a new ring. Down here, I'm going to write period 2, and what block is boron in?
P.
It's in P block. All right, now, how many electrons fit in P block? Well, count across. There's boron, carbon, nitrogen, oxygen, fluorine, neon. 6 electrons can fit in P block. Now, I'm going to put those down here on the bottom, and I'm going to put them as open-faced circles. Boron, carbon, nitrogen, oxygen, fluorine, neon. Down here, 6 electrons fit in. My electron counter goes from 4 to 10. 4 to 10. Okay? Now, notice we're at neon, right? And neon is in period 2, and it's an inert gas in Roman numeral group 8A. So it should have 8 valence electrons on the outermost ring. There they are. There's 2 there, and there's 6 more there. The outermost ring contains the valence electrons, right? So this is okay. What we have so far is correct. So our fingers on neon. What's the next element after neon?
Sodium.
Sodium, which is in period 3, so I'm going to need a new ring. a third ring. And down here, I'm going to write period 3, and sodium is in S block. And again, how many electrons fit in S block? 2. 1 for sodium and 1 for magnesium. 1 for sodium, so there's sodium, 1 valence electron, there's magnesium, 2 valence electrons. So here I'm going to write 3s2, and electron counter goes from 10 to 12. So again, there's magnesium, alkaline earth, 2 valence electrons. So my finger is on magnesium. What's the next element? After magnesium?
Aluminum.
Aluminum. Still in period 3, so I don't need a new ring. I do not need a new ring. All right? But over here, I'm going to write period 3, P block. Now, we know 6 electrons fit in P block, but we only need 4 more, right? Because I'm at 12 and I only need 16. So I only need 4 more electrons. So I'm going to put 4 P electrons down here on the bottom, right? So aluminum, silicon, phosphorus, sulfur. Here I'm going to write 3p4. My electron counter goes from 12 to 16. Okay, are we finished? Are we finished? The answer to that is no. We should always check our work. We should always check our work. We did all this work. Spend a few more seconds to check and make sure that it's right. Because these electron configurations are either right or wrong. These atom drawings are either right or wrong. So what can we check? Well, the first thing is that the total number of electrons is correct. Right? And this is one reason why I separate the S from the P electrons. And in a moment, we'll see we're going to separate D electrons also. It makes it far easier to count them. Right? So here I have 6. Here I have 6 is 12, 4 more there is 16. Now remember, in the electron configuration, I have period, block, and how many electrons. So if I add up these superscripts, I should get 16. 2, 4, 10, 12, 16. Is there anything else we can check to make sure this is right? Anything else we can check? Total number of electrons we check. We can check the number of valence electrons. Okay, sulfur is in what Roman numeral group? It's in 6A. 6A, right? So if it's in Roman numeral group 6A, it should have 6 valence electrons. There they are, 2 there and 4 there. There's 6. And in the electron configuration, what I like to do is underline the highest period number, which is 3. And I should have 6 valence electrons there. 6 valence electrons there. Okay? So that's about all we can really check, right? Sulfur's in period 3 with 6 valence electrons. So I should have 6 electrons on the third ring. Okay, any questions or comments? Any questions or comments? Okay, nobody has any questions or comments. Now, I do want to warn you about one thing where you might make a mistake. Every year I see this. People begin, and again, it's because of helium. People want to write, instead of 1s2, they want to say, okay, hydrogen's in 1s, and then helium is in 1p. So instead of writing 1s2, they'll write 1s1, 1p1. Okay? But you can't do that. There is no p block for there is no p electrons in period 1. Right? The electrons don't begin until period 2. So again, for a lot of times during the course, we're going to think of helium as being in group 2. And again, the only reason that Mendeleev put it in period, in group Roman numeral group 8A is because it's an inert gas. And the inert gases are all in Roman numeral group 8A or group 18. Okay? Any other questions or comments? Any other questions or comments? Okay, so I'll erase this and we'll do another one. So now you may want to start writing these down. All right, I just wanted you to see the first one done without, where you could just focus on the board here. Oop, wrong way. All right. So, wish I could open my windows. I don't want my apartment to stink from all that forest fire. Okay. So anybody have an atom we want to draw? Let's draw. Anybody here? Let's draw calcium. Calcium. So calcium has 20 electrons. Okay, and again, if you have a question or comment at any point, don't hesitate to stop and ask. So we're going to begin with period 1, hydrogen. Right, there's the nucleus. How many protons are in that nucleus, by the way? Anybody? How many protons are in that nucleus?
20.
20.
20. Right, same as the atomic number, right? Same as the atomic number for calcium. All right, so we're going to begin with hydrogen, period 1. Down here, I'm going to write the electron configuration. Period 1, hydrogen is in S block. And 2 electrons fit in S block. 1 for hydrogen and 1 for helium. 1 for hydrogen, 1 for helium. Period 1, S block, 2 electrons. Electron counter goes from 0 to 2. So my finger's on helium. Next element is lithium in period 2. So I need a new ring here. I need a new ring, period 2. Okay, so down here, electron configuration, period 2, S block, and again, 2 electrons are going to fit there. 1 for lithium and 1 for beryllium, right? 1 for lithium and 1 for beryllium. So down here, period 2, S block, 2 electrons. Electron counter goes from 2 to 4, 2 to 4. Okay, what's the next element after beryllium? Well, I got to jump over into P block, right, to boron. Boron is still in period 2, so I don't need a new ring. Don't need a new ring, right? But down here, I'm going to write period 2, P block, and let's not write the 6 yet. We're going to put 6 electrons in, right? So boron, carbon, nitrogen, oxygen, fluorine, neon. There's a neon atom. So period 2, P block, 6 electrons. Electron counter goes from 4 to 10. So I'm at neon. 8 valence electrons on the second ring for neon. Okay? Next element after neon is sodium, which is in period 3. Now your finger you should be writing with one hand, and your other hand, you should be moving along the periodic table if you have one in front of you. All right? So the next element is sodium, which is in period 3. So I need a new ring, third ring. So here I'm going to write period 3, S block. Period 3, S block. And how many electrons fit in S block? 2. It's always 2. That's why there's 2 groups in S block. So there's a sodium atom, 1 valence electron, and magnesium, 2 valence electrons. Down here I'm going to write period 3, S block, 2 electrons. 2 electrons. So here my electron counter goes from 10 to 12. Notice, do every one of these the same. Draw, write the electron configuration, electron counter. Do every one of them the same. Right, so now my finger is on magnesium. Next element after magnesium is still in period 3. We jump over into P block at aluminum. So our finger is on aluminum now, period 3, P block. So I don't need a new ring. Here I'm going to write period 3, P block, and 6 electrons fit in P block. So, and we need all 6 this time. So I'm going to write aluminum, silicon, phosphorus, sulfur, chlorine, argon. Right? So 6 electrons in 3p. Period 3, P block, 6 electrons. Electron counter goes from 12 to 18. 12 to 18. I'm going to stop for a moment and get a sip of water. Okay. So we're at argon now. Next element after argon is what?
Potassium.
Potassium, which is in what period?
4.
4. So I'm going to need a 4th ring here. A 4th ring. All right, so down here I'm going to write period 4, potassium is in S block. Okay, and let's see. We need, S block holds 2 electrons and we need them both. We're at 18 now, and we're going to finish at 20. So there's a neutral potassium atom, 1 valence electron, and there's a neutral calcium atom, 2 valence electrons. So down here, period 4, S block, 2 electrons, electron counter goes from 18 to 20. Now, seemingly we're done. So we're going to stop and check our work. I should have 20 electrons. 20 electrons. So let's see. I have 2, 4, 6, 8. 6 more there is 14. 6 more there is 20. So that's good. If I add up all these superscripts, I should get 20. 2, 4, 10, 12, 18, 20. So that's good. The only other thing we can check now is the valence electrons. Calcium is an alkaline earth in period 4, so I should have alkaline earth means group 2, so 2 valence electrons on the 4th ring. There they are. 2 valence electrons on the 4th ring. Underline the highest period number down here. There they are. 2 electrons on the 4th ring. Right? So is that a guarantee that what we have done is correct? No. But if you like to bet, I would bet that this is correct. Right? I would bet that this is correct. I'm going to tell you, look, one of the best way to succeed in this class is to follow my advice. Do things the way I tell you to do them. All right? Count the electrons at the end. Count the electrons at the end in both the drawing and the electron configuration. Count them. It's amazing how many times every year, every semester, I count electrons, and people have the wrong number of electrons here. I'm sorry, I can't give you any credit for that. If you don't have 20 electrons, you didn't draw a calcium atom, a neutral calcium atom. You drew some other element. Okay, count the electrons here and here. Check the valence electrons in both the drawing and the electron configuration. Okay? Any questions or comments? All right, we'll draw another one then. Let's see, where's my eraser? There it is. All right, now this one's going to be a little bit different. So pay attention to this one. All right, this is pretty straightforward. It's pretty easy. It's pretty easy to do this. So this time, let's draw a neutral. Let's draw an iron atom. All right, an iron atom. Atomic number 26, so I'm going to need 26 total electrons. So as always, we're going to begin with hydrogen in period 1. So 1 ring, period 1, S block, and 2 electrons fit there, hydrogen and helium. Period 1, S block, 2 electrons. Electron counter goes from 0 to 2. 0 to 2. Okay? All right. So the next element is lithium. Lithium is in period 2, so I need a sorry?
Period 2. I said group 2, but it's period.
All right, so I need a new ring. Lithium's in period 2, so down here, electron configuration. Period 2, S block, 2 electrons. 2 electrons. And I'm going to put them up here. Actually, I shouldn't have written that first. There's lithium and beryllium. Okay, I've already written a 2 here. So I'm going to go from 2 to 4 in my electron counter. 2 to 4. All right, so my finger's on beryllium. Notice we're filling electrons by blocks. We're not doing them one at a time. We're doing them by blocks. All right, S, P, or D. All right. Now my finger's on beryllium. So the next element, jump over into P block, is boron. All right, it's still in period 2, so I don't need a new ring. Down here, electron configuration, period 2, P block, and let's see, P block holds 6 electrons. So that, again, down on the bottom, I'm going open face circles for the P electrons. There's boron, carbon, nitrogen, oxygen, fluorine, neon. So here, period 2, P block. If I'm going too fast, somebody speak up. All right, if I'm going too fast. Okay, so up here, electron counter goes from 4 to 10. 4 to 10. Okay, all right, so my finger's on neon. And again, neon should have 8 valence electrons, which this atom does. All right, so next element after neon is sodium, which is in period 3. So I need a 3rd ring here. I need a third ring. All right, so down here, I'm gonna write period 3, and sodium is an S block. And in S block, we can hold 2 electrons, 1 for sodium and 1 for magnesium. All right, so here I'm gonna write period 3, S block, 2 electrons. Electron counter goes from 10 to 12. 10 to 12. All right, so my finger's on magnesium. The next element is aluminum, which I have to jump over into P block, still in period 3, so no new ring. All right, but down here, period 3, S block, or P block, all right, and 6 electrons fit there. So aluminum, silicon, phosphorus, sulfur, chlorine, and argon. All right, so down here, period 3, P block, 6 electrons. My electron counter jumps from 12 to 18. So we're getting close. We're getting close. All right, so next element is, after argon, is potassium, right, which is in period 4, so I need a new ring. I need a new ring, period 4, 4th ring. All right, so down here, I'm gonna write period 4, and potassium is in S block, S block. And I know 2 electrons fit in S block. So there's potassium, and there's calcium, the one we drew last problem. So down here, I'm gonna write period 4, S block, 2 electrons, 2 electrons. Okay, my electron counter jumps from 18 to 20. Now we're awful close. We're awful close. We're only 6 away now. All right, everybody can see the board? Okay, all right. Now, so my finger is on calcium, right? What's the next element? Come on, somebody. What's element 21? You got the periodic table right in front of you. Come on, somebody speak up.
Scandium.
Scandium. What block is scandium in?
It's in D block.
It's in D block. Pay attention here. All right, so D block holds 10 electrons, but I only need 6. All right, so I'm going to put 6 electrons here. So there's scandium. All right, there's titanium, vanadium, chromium, manganese, and iron. Iron. Okay, so down here I'm going to write period 3, D block, and 6 electrons. Electron counter goes from 20 to 26. Okay, any questions? Somebody should have a question.
Wait, why is it D?
Why is it D? Well, because scandium through iron is in D block. Scandium through iron is in D block. That's so notice I use triangles.
Period 4.
Louder?
Put it on period 3.
Yes, there's the question I wanted someone to ask. For D block, you have to drop back 1 period number or 1 ring. All right? Now, we'll see why on the next one. We'll see why on the next one. But just remember, for when you hit D block, you have to always drop back 1 period number. You must always drop back 1 period number. All right? We'll talk more about that on the next problem here. But let's check 26. We should have 26 total electrons. Now, again, this is why I separate them, so I can count them quickly. There's 8 there. Look, 8 there. There's 6 more for the D. That's 14, 20, 26. So I can count them real fast if I have them separated. All right? So here I'm going to add up the superscripts. I should get 26. 2, 4, 10, 12, 18, 20, 26. 26. Okay? My highest period number is 4. So there's my valence electrons. And here's my valence electrons here. Notice that everything in D block will have 2 valence electrons. Right? Everything in D block will have 2 valence electrons. All right? Now, we have to do one more thing here. Pay attention. Pay attention. All right? What I'm going to do is I'm going to take this 3d6 and I'm going to move it to here. All right, so I'm going to rewrite this as 1s2, 2s2, 2p6, 3s2, 3p6, 3d6, 4s2. And you should go back and count them again. 2, 4, 10, 12, 18, 20, 26. Okay? Now, I'll give you a chance to write that down. Then I'll say why we did that. There's so many dang forest fires, I can't even tell which one the smoke is from, the smell is from.
Honestly.
Okay. So why did I rewrite this? And we do this by convention because when you're writing the electron configuration, you want to order the electrons from lowest energy electrons to highest energy electrons. Again, from lowest energy electrons to highest energy electrons. And 3D is lower in energy than 4s. So this is why we rewrite the electron configuration. You only need to do that if you have d electrons. Right? You only need to do that if you have d electrons. Now, while we're doing this, I'm going to mention that for f block electrons, you would drop back 2 rings. 2 rings. But I will never give you an f block element to draw. All right? I'll never give you an f block atom to draw. It starts to kind of get too complicated there. Okay, do we have any questions or comments? Again, on the next problem, we will see why we drop back a ring for D block. Okay? Now, one thing I want to point out here while we have this up here with S electrons, P electrons, and D electrons. All right? I don't want you leaving here today thinking that in an atom, all the S electrons are on one side, all the P electrons are on the other side, and the D electrons are on another side. That's not the way it is. Remember, these are circling around the nucleus, right? Orbiting the nucleus. And even that is a very, very primitive view. But for our purposes, it will suffice. Okay, this is a very, very simplified view. I also don't want you to think that S electrons look different from P electrons, look different from D electrons. Every electron looks just like every other electron. Okay? So the only reason I draw them differently here is so I can count them very quickly at the end. When you start getting up to 10 with like 50 electrons, or barium with 56 electrons, right? You don't want to be counting them one by one. You have them separated by block like this, you can count them very, very quickly. Just like 2 seconds, you can count 50 electrons. Okay? So this is why I draw them like this. You won't see this anywhere else in a textbook or on the internet. They're going to draw them all looking the same. You can count them very, very fast this way. Very, very fast. Most of the time, you're only interested in the electron configuration. You're not interested in drawing them. But since for some of you, this is your first chemistry class, I want you to get a feel for how the electrons are arranged in an atom. Again, this is a very, very primitive view. In reality, the electrons aren't arranged like this whatsoever. If you want to find out more about that, you can take general chemistry. We talk about that in general chemistry. Right? The electrons are actually waves. They have wave-like behavior in atoms more so than discrete particles, which is how we're drawing them here. Right? The way we're drawing them here, each electron is a discrete particle. But that's not the way it is in reality whatsoever. We don't need to worry about that. For our class, we'll treat them as discrete particles. And if you're worried about the wave interpretation, take general chemistry. All right, any other questions? So again, we counted the electrons, check the valence electrons, and when you have d electrons, you got to make sure that you rewrite the electron configuration. Okay? Any other questions or comments before I do another one here? All right, so this time we're going to draw Anybody have one we want to draw? Why don't we draw, let's draw bromine. Bromine. Here, I'm going to show you what I used to make my high school students do. All right? Let's not say bromine. Let's say, now I just gave it away that it is bromine. But let's just say we're going to draw the halogen in period 4. The halogen in period 4. So how am I going to know how many electrons to draw? I don't have a periodic table in front of me. All right. But I do know the halogens are what Roman numeral group? How many valence electrons do halogens have, in other words? Anybody? Uh-oh. I might lose you here. Oh, geez. I don't know why hopefully I caught that in time. I don't know why my power things keep shutting off. Okay. Come on, what group is the halogen? Somebody.
In group 17.
Group 17. What Roman numeral group number is that?